object or material is expanded.
Okay, but which are the factors that affect thermal expansion? What do you think?
Heat may be a factor.
Heat.
And material or like surface area.
Very good. And the material, both of them, temperature and material, because today we'll discuss about how the type of the substance affect this method of heat transferring. Why not conduction and convection? Because different substances have different atomic structure or we have different states of matter. It means the arrangement of particles in different states is differently, okay? Okay, so let's see today what is convection as a method or way to transfer heat. Now, is the unit 11.5 on your science book? Before getting what is convection, let's see what is energy again. Now we have discussed for energy that is just the ability to do work. But in this part, at convection, conduction, and radiation, energy is the ability to cause a change. And why not a change in state, for example? Because when you heat something up, you can cause a change in its state. For example, when you heat ice, when you increase its temperature, what happens to ice? It turns into water, and so on. So we can define energy at this part as just the ability to cause a change. Now we have many forms of energies. We have classified it in two types. General ones, kinetic, related with movement, motion, and potential, that is a stored energy. At potential one, don't forget that we have classified all forms of energies that are related with energy that is stored inside, for example, a battery. Why not? And then it changes in different forms. If you remember the electricity, we have learned that chemical energy that is inside the battery, when it comes out, what happens? It turns into electrical one. Now, let's recall something about states of matter. Why is it important to recall states of matter? Because we said that energy is something that causes a change in state. Now, to understand what happens with particles when you heat something up, a substance, a material, a metal on a metal, and so on, we should understand firstly, what about the states of matter? I think that you have learned previously all the states of matter, how they are made up, how particles act in each state, but let's recall them together. Darius, what do you remember about solid state, Darius? Darius? Oneida? What about solid state?
Particles in a solid state are held tightly together, and they only vibrate.
They vibrate in a fixed position.
Yes,
now,
so they do not
move. What about
move.
their shape and volume? What about shape and volume at this state of matter?
Shape,
definite shape. And definite?
They have a definite shape and a definite volume.
And definite volume. Okay, good. Now, what about a liquid one? So suppose that you increase the temperature, you heat a solid state up. What happens to the particles? Rhea?
In the liquid state, the particles slide against each other, and they're not tightly together as in the solid state. So they have more space between them.
Clearly, they do not vibrate in a fixed position as they do in solid state. Now, what about shape and volume at liquid state, Rhea?
They do not have a fixed shape, but they have a fixed volume.
Good, because they take the shape of the container when you pour them on. Okay, yeah. Good, well done. Agnesa, what about gaseous states, Agnesa?
Özürsem should be mute.
Okay.
In gas state, the particles are can move freely. They can move past freely from each other. There is no definite shape or volume.
Good. they move at high speed in different directions. Collision
Yes.
starts to happen, and then because they gain more energy. Okay, good, well done. Now, let's see. How can heat affect the states of a matter or just a matter? Now, heat and states of matter. Now we discussed about states of matter like solid, liquid, and gaseous states. But when you heat them up, we said that they gain energy and then they cause a change. Now, states of substance depends on the speed of the particles. On the speed of the particles. By adding or removing heat, we can result in a change in state. How? An example, you have a diagram that represents how ice is changed into liquid water or in water vapor. Adding heat, for example, to ice cube changes it from the solid into a liquid one. Now, when ice changes into liquid water, it absorbs heat. By absorbing heat or adding or gaining heat, what happens? It changes into another state of matter. So at ice, you have the first state of matter, solid one, where particles are vibrating in a fixed position, they have a regular shape, and then by this process known as melting, they turn into liquid water. But if you heat or increase the temperature to liquid water, what happens? It will start to evaporate and it changes from liquid into water vapor. Again, what happens? Energy is absorbed in this process. Pay attention to the reverse one. For example, to turn from water vapor into liquid water, we have condensation as process. And then from liquid water into ice, again, we have freezing. Pay attention, at this process, we don't have absorption of heat, but we have the heat that is released, or the energy is released by the water, in this case, at the reverse process of melting. So melting, the reverse one, or the opposite one, of course, there is freezing. At evaporation, we have condensation and so on. So this is the way how heat can cause a change in state. By adding heat, by increasing its temperature, particles start to slide over each other from ice into water, liquid, they move freely, and if they gain more heat, they start to evaporate. So to turn it into water vapor. So this is the way how temperature and heat affect states of matter. Now let's discuss about convection, the second way that is used to transfer heat. Last time I said that conduction has a special condition, the contact between objects with different temperature. They start to exchange heat by rising the same temperature. So this is the first condition. And the second one, if you heat a material, a metal, for example, we said that the material itself do not move, but are particles those that transfer heat inside the material. But what about convection? The transfer of energy is heat by the movement of liquid or gas. It is known as convection. In most substances, as temperature increases, density decreases. Why? Because if you heat something up, a liquid, or why not a gas, what happens with particles? They start to being far apart from each other. So the density of the liquid or the gas, it decreases. Convection happens when a cooler or denser fluid, that fluids we include both of them, liquid or gas, replaces the warmer, less dense mass of the fluid. And as you see right here, that represents convection, you have a circular way, a circular motion of air that represents how convection happens. The red particles are those that represent the warmer particles of the air. And as you see, they make a circular motion by producing this kind of effect known as convection, Now, convection as method of heating creates a convection current. What does it mean? Let's see it at the next page. Now, suppose that you have a radiator. We use them in our houses to warm our rooms, but how it works. Now, as you see, the diagram right here represents the warmer air that is at the upper part of the radiator. Now, what happens with the warmer fluid? Particles move faster, and as you see, they are apart from each other. Particle spreads out, increasing volume. As they are spreading out, it means the volume, of course, that is greater. But what about their density? Density becomes less dense as fluid in this case, because the distance between them is greater. It means that, again, density becomes less dense and the fluid rises, As you see, the warmer air goes up. But what about the cooler one? Now, when the warmer air goes up, when it touches the wall of the room, or why not the window that it has lower temperature, they make a circular motion and they sink. But why? Because cooler fluids, particles move slower. Particles come together by decreasing the volume. Can you check the diagram again? So right here, particles are far apart. They are smaller, they have a greater volume and less density. What about the second diagram with cooler fluids, or air in this case, as we have cool air at radiator, at the lower part of the radiator? Now, the volume decreases, density increases because particles are more close to each other, and then fluid. So we can see that the air right here is heavier, and then it goes down. Density increases and fluid sinks in this case. So a general diagram that represents how the hot radiator makes this circular motion known as convection, or just convection current, is this one. So the radiator warms the room by warming the air around it. Then the warmer air transfers heat to the rest of the room through this process known as convection. And as you see, again, you have the same diagram: warmer air rising, cold window induce it to fall down, cool air falling, comes to radiator again, warmer air rising because we said that it has less density, greater volume but less density. So it means that particles are lighter, and then they are free to go up by making this circular motion, known, as I said, as a convection method of transferring heat. Now, how this process happens during daytime and during nighttime. Now, again, you have a diagram that represents how convection happens. Now, again, you have a circular motion that represents wind that blows toward the coast. The warm air rises according to its density, because it's less denser, and then air cools down. The cold air, we learned that it sinks. Why? Because its density increases, so particles are more heavier. Now, during daytime, where the sun shines, the land heats up more quickly than the sea, and then above the land, warm air rises and the wind blows towards the coast. This is the way how wind acts and makes this circular motion known as convection current. This diagram represents how wind or air acts during daytime. But what about night? At night, the land cools down quickly while the sea stays warm. Above the sea, warm air rises and wind blows away from the coast. So pay attention, we have a different direction. Can you check right here? Wind blows towards the coast. This is the way how convection happens. At night, it has an opposite direction. The reason is this: the land cools down quickly while the sea stays warm. And then above the sea, the warmer air rises and the wind blows away from the coast, not towards the coast. And then you have again another diagram that represents how convection current in this case happens. So wind blows away from the coast, the air becomes less denser, warmer air rises, and then the air cools down according to different factors, and then the air, or the colder one, it sinks because it becomes more denser. It decreases its volume and particles are heavier in this case, so they fall down. This is the shortest way how convection happens as method. As you checked right here, is according to the movement of fluids. At fluids, we involve both gas and liquid one. We had both of the matter, and we said that heat can cause a change in state. Now, for next time as homework, you will have the questions that you have on your science book at the same topic, and summarize information at the end of the topic that you have about convection is this one. Convection is the transfer of heat through fluids. When the fluid itself, it moves. So pay attention. At conductors, we said that materials do not move, but just particles inside, except having two materials in contact with different temperature with each other. And then, as you see at convection, the transfer of heat happens when fluid itself moves. At fluids, we involve both liquid and gas. Warmer fluids are less denser, and then they float upwards through the cooler fluids. If you can check this diagram, it represents how conduction happens. So as you see, you have two objects in contact. The red one, it represents the hotter object, and then as you see, the heat is transferred from the hotter into the colder one. What about convection? Can you check how it happens? So it's just by the movement of the fluids, the air, the liquid, the gas, and so on. And next time we will see what about radiation. So at convection, we do not have conditions as we have at conductors. So to being in contact and to see this way of transferring heat.